The ground beneath us hides stories of lost worlds and forgotten disasters. Ancient cataclysms, etched into stone and ice, reveal moments when Earth itself seemed to rebel, reshaping continents and rewriting human destiny. By the end of this exploration, you will uncover 20 of the planet's most baffling geological mysteries, events where the evidence is clear but the cause remains a profound enigma. What could have triggered a sudden global winter just as early civilizations were emerging? How did entire species vanish from the record, leaving behind only cryptic clues in the soil? Each layer of rock holds a piece of this puzzle, waiting for us to listen. What do you believe is the greatest force shaping our world's hidden history? These silent archives are not kept in libraries, but locked within the very substance of our planet. To read them, we must learn the language of the Earth itself. Geologists act as translators, deciphering a history written in stone, ice, and ancient life. They examine the stacked layers of rock, each one a page in a chronological book, with the oldest stories at the bottom and the most recent at the top. A sudden, dark line of ash within these layers speaks of a colossal volcanic eruption that once choked the skies. A deposit of unusual pebbles and sand, far from any coast, can be the ghost of a mighty tsunami. Even the slender rings of a long petrified tree hold secrets, their narrow bands whispering of years when sunlight faded and the world grew cold. One of the most startling clues comes from an element so rare on Earth's surface it should not be here in abundance: iridium. When a thin layer of iridium-rich dust is found all across the globe, dating to the same exact moment in time, it points to a single, shattering conclusion: an impact from space. These are the tools that build our understanding of deep time, allowing scientists to reconstruct timelines of catastrophe with remarkable precision. Yet for all our advanced technology, some of these ancient events leave behind a trail of evidence that simply does not lead to a clear answer. The clues are there, solid and real, but the culprit remains a phantom, hiding in the gaps of our knowledge and fueling endless scientific debate. By understanding how we listen to the Earth's story, the profound mysteries we uncover next become all the more astonishing. A thin, dark line in the Earth, found from California to Syria, marks a moment when the world turned upside down. This is the boundary of the Younger Dryas, a geological layer that tells a story of sudden, catastrophic change. Around 12,800 years ago, just as the last ice age was loosening its grip, the planet was plunged back into deep freeze. Temperatures in some regions plummeted by as much as 10 degrees Celsius in a matter of decades, a geological blink of an eye. The evidence for what caused this shock is both compelling and deeply controversial. Researchers have uncovered a strange sprinkling of materials within this layer, including microscopic nanodiamonds and tiny spheres of glass that only form at temperatures hotter than a volcanic eruption. These substances are scattered across North America and Europe, a calling card for an immense force. The most logical explanation is an impact from space, a comet or asteroid that shattered in the atmosphere or slammed into the ice sheets that once covered much of the northern hemisphere. The resulting energy would have been unimaginable, triggering wildfires on a continental scale and throwing so much debris into the air that it blotted out the sun for generations. The consequences were devastating for the planet's great beasts. Creatures like the woolly mammoth and the giant ground sloth, which had survived the harsh ice age for millennia, suddenly vanish from the fossil record. Their bones are often found in tangled accumulations, alongside the distinctive layer of black matte sediment that defines this catastrophic event. This was not a slow decline, but a sudden, brutal end for an entire world of megafauna. For the early human communities of the time, this would have been an existential challenge. Societies that were just beginning to establish themselves faced a rapidly shifting world, with familiar hunting grounds disappearing and climates becoming unpredictable. The very fabric of their survival was tested, yet the impact hypothesis is not without its fierce debate. The central mystery persists: where is the crater? No single definitive impact site has been found, leading some scientists to propose a fragmented comet that exploded in a series of airbursts, like the Tunguska event in Siberia, but on a global scale. This lack of a smoking gun keeps the investigation alive and contentious. The story of the Younger Dryas impact is a powerful reminder that our planet's history is not always one of gradual change. It can be a record of sudden, violent pivots where the evidence is clear, but the final answer remains just out of reach, a ghost in the geological machine. The ghost of a lost world lies beneath the waves of the North Sea. While the Younger Dryas presents a mystery written in fire and ice, our next cataclysm unfolded in the crushing silence of the deep ocean. Around 8,200 years ago, the continental slope off the coast of Norway collapsed. This was not a simple shift of mud, but the single largest underwater landslide ever identified. Known as the Storegga Slide, it sent over 3,000 cubic kilometers of sediment rushing into the abyss. To grasp that scale, envision a mountain range simply giving way and flowing across the seafloor. The energy released was beyond comprehension, and it displaced an immense volume of water, generating a tsunami that radiated out across the North Atlantic. The wave did not simply dissipate into the open ocean, it marched toward coastlines with terrifying force. Sediment cores pulled from seabeds and coastal plains tell a clear story, with layers of sand and marine debris thrust far inland, a stark signature of the wave's passage. But what could cause such a monumental collapse? The slopes had been stable for millennia, so what was the final trigger? Some researchers point to post-Ice Age earthquakes as the land, freed from the immense weight of glaciers, slowly rebounded. Others investigate the potential role of methane hydrates, icy deposits trapped in the seafloor that can turn from solid to gas with a slight change in pressure or temperature, potentially liquefying the sediment and causing it to fail. The true catalyst remains locked within the submarine geology, a puzzle that continues to challenge our understanding of stability itself. This event was far more than a geological curiosity, it was a human tragedy. At the time, the North Sea was not a sea at all, but a vast, low-lying plain known as Doggerland, a verdant landscape that connected Great Britain to mainland Europe. Mesolithic communities hunted, fished, and made their homes on this fertile land. The Storegga tsunami would have swept across this entire region, transforming it from a homeland into a death trap. The wave, possibly tens of meters high, would have scoured the low-lying coasts, with the aftermath permanently reshaping the map of Europe. The precise impact on these early societies is a subject of intense investigation, as the very evidence of their lives was either washed away or submerged by rising seas. The story of the Storegga Slide is a humbling lesson in hidden vulnerability. It reveals that some of the most powerful forces on our planet operate out of sight, beneath the placid surface of the ocean, capable of unleashing devastation that echoes for millennia and erases entire landscapes from human memory. 74,000 years ago, a mountain in Indonesia tore itself apart in what stands as the most violent volcanic eruption our species has ever witnessed. The Toba supereruption was not merely a large volcanic event. It was a planetary-scale detonation, ejecting so much rock and ash into the atmosphere that it created a caldera visible from space, which now forms the serene expanse of Lake Toba. The sheer scale of this event is written in a layer of ash that can be traced from the eruption site all the way to the heart of Africa, a ghostly blanket that settled over continents. This global signature tells us the entire Earth felt Toba's fury. The immediate aftermath would have been a world plunged into a profound twilight. Sulfate aerosols and fine ash particles formed a veil around the planet, reflecting sunlight back into space and triggering a volcanic winter that may have lasted for a decade or more. Ice cores from Greenland and Antarctica capture this moment as a sharp spike in acidity, a direct chemical record of a sky filled with volcanic pollution. Temperatures plummeted globally, with some estimates suggesting a drop of up to 5 degrees Celsius, enough to disrupt growing seasons and collapse ecosystems worldwide. The impact on life would have been catastrophic. For the small, scattered populations of early humans, this was an existential bottleneck. Genetic studies suggest that around this time, the human population may have shrunk to just a few thousand breeding individuals, bringing our species perilously close to the brink of extinction. Every person alive today may be descended from that small, resilient group who somehow survived the long, cold years after Toba. Yet, the true severity of this event remains one of geology's great debates. Did the eruption single-handedly push humanity to the edge, or were our ancestors already facing other pressures, with Toba simply exacerbating an existing struggle? The evidence is complex and open to interpretation. Some archaeological sites show continuity of human occupation, suggesting certain groups weathered the storm better than others. The debate forces us to ask a profound question about our own past. How much of our existence today is owed to pure chance, to the resilience of a few communities who found refuge in a world suddenly turned hostile? The caldera itself, now a beautiful lake, offers no simple answers as to why the eruption was so colossal. The forces that build such immense reservoirs of magma deep within the Earth, and the triggers that cause them to empty in a single catastrophic event, are still not fully understood. The legacy of Toba is a humbling reminder of the fragile thread of human history, a thread that was nearly severed by a geological event of unimaginable power, leaving us to unravel the story of our own survival from the dust it left behind. The sheer power of water to reshape a continent is written across the desert of eastern Washington. Here, a vast and bizarre landscape known as the Channeled Scablands stretches to the horizon, a place of deep, dry canyons and strange, isolated buttes that look less like a product of slow erosion and more like the work of a furious, impatient force. For decades, this terrain baffled geologists who could not reconcile its features with any known process. The mystery was solved by one man, J. Harlan Bretz, who in the 1920s proposed a radical idea that this entire region had been scoured by a flood of unimaginable scale. His colleagues were deeply skeptical, as the idea flew in the face of the prevailing belief that geological change was always gradual. But the evidence on the ground was undeniable. The scablands are crisscrossed with enormous channels, some hundreds of feet deep, that seem to have been carved in a single, violent episode. Most telling of all are the giant ripple marks. These are not the small ripples you see on a beach, but colossal waves in the earth itself, some standing 30 feet high and spaced hundreds of feet apart. These features could only have been formed by a torrent of water moving at catastrophic speeds, a deluge that would make any modern river look like a tranquil stream. The source of this water was a giant Ice Age lake, Glacial Lake Missoula, held back by a towering ice dam in what is now northern Idaho. When that dam failed, it released a wall of water equal in volume to Lake Michigan and Lake Erie combined, racing across the land at 60 miles per hour. The landscape we see today was sculpted in a matter of days, perhaps even hours. Yet the story is even more complex. The geological record suggests this was not a single event, but a cycle of destruction that repeated itself dozens of times over 2,000 years. The ice dam would reform, the lake would refill, and the pressure would become too great, unleashing another cataclysm. This cycle of destruction and rebirth is recorded in the layers of sediment, with deposits from successive floods stacked atop one another. The fundamental puzzle that remains is what precisely triggered each failure. Was it a slow warming of the climate that gradually weakened the ice? Or was it a more sudden, internal collapse caused by the sheer weight and pressure of the water itself? The interplay between a shifting global climate and the unstable mechanics of a miles-wide ice dam is a dynamic that geologists are still working to fully model. The legacy of the Missoula Floods is a humbling lesson in the sudden, transformative power of water. It shows us that continents can be remade not over eons, but in a single, breathtaking instant, leaving behind a scarred and beautiful monument to one of Earth's most spectacular and unresolved cataclysms. Far out in the Aegean Sea, a volcanic island named Thera, now known as Santorini, held a secret within its core. Around the year 1600 before the Common Era, that secret was unleashed in one of the most devastating eruptions in human history. The geological evidence is staggering. The center of the island collapsed into the sea, forming a vast caldera that today is one of the deepest marine basins in the world. The eruption ejected cubic miles of pulverized rock and pumice, leaving behind deposits hundreds of feet thick on what remained of the island. This volcanic ash became a global time marker, a distinct layer found deep within ice cores from Greenland and layered into the seabed across the eastern Mediterranean. Scientists can trace this chemical signature like a fingerprint, confirming the eruption's colossal scale. But pinpointing the exact year of this cataclysm has proven to be a monumental challenge. Radiocarbon dating from olive wood buried in the ash provides one range, while studies of ice core acidity and tree rings from other parts of the world suggest slightly different dates. This discrepancy of decades may seem small, but it holds the key to understanding the eruption's true role in the ancient world. The most profound impact was felt just 70 miles to the south, on the island of Crete, the heart of the sophisticated Minoan civilization. The Minoans were a maritime power, their palaces adorned with vibrant frescoes and their culture flourishing. The Santorini Eruption would have been an event beyond their comprehension. First, a series of earthquakes would have shaken their world, a terrifying prelude. Then, the sky itself would have darkened for days as a towering column of ash blotted out the sun. Finally, a tsunami generated by the collapse of the caldera would have raced across the sea, slamming into the northern coast of Crete with unimaginable force. The wave would have devastated the Minoan fleet and their crucial coastal settlements, the very foundation of their wealth and power. The ash fall would have poisoned farmlands and crippled agriculture for years. While the Minoan culture did not disappear overnight, it was irrevocably weakened, entering a period of steep decline from which it never recovered. This direct link between a geological event and the fall of a great civilization is what makes Santorini so compelling. It has led many to wonder if this was the real-world inspiration for the legend of Atlantis, the story of a magnificent island kingdom that sank beneath the waves in a single day and night. The parallels are striking: an advanced civilization on an island, brought low by a sudden, catastrophic event from the sea and the earth. While we may never know if Atlantis was a direct memory of Thera, the eruption certainly demonstrates how a single geological cataclysm can etch itself into cultural memory, transforming from a historical event into a powerful myth that echoes for millennia. The search for the definitive date of the Santorini eruption continues, a puzzle that connects tree rings, ice layers, and ancient pottery shards. Each new piece of evidence brings us closer to understanding not just the power of the volcano, but the precise moment it changed the course of human history in the Mediterranean, leaving behind a beautiful, broken island and a mystery that still captivates us today. While the Mediterranean faced fire from Thera, another kind of deluge was reshaping coastlines across the entire globe. Deep within marine sediment cores, pulled from the ocean floor worldwide, lies the record of a different kind of cataclysm, one of silent, overwhelming floods. These are the meltwater pulses, moments near the end of the last ice age when colossal volumes of fresh water, long trapped in continental ice sheets, were suddenly released into the world's oceans. The evidence is written in the chemistry of tiny fossil shells and the layered mud of the seabed. When a vast pulse of cold, fresh water poured into the salty Atlantic, it left a distinct chemical signature, a ghostly fingerprint of a world in flux. These were not single events, but a series of rapid sea level rises that would have been perceptible within a human lifetime. Imagine standing on a shore and watching the ocean slowly, inexorably, claim the land your ancestors had lived on for generations. Over just a few centuries, global sea levels could have risen by several meters, drowning vast coastal plains and forever altering the map of the world. The sheer scale of these floods is almost beyond comprehension, with some pulses potentially releasing a volume of water equal to multiple Greenland ice sheets in a geological instant. But what triggered these sudden, colossal releases? The mechanics of the decaying ice sheets are a source of intense debate. Some researchers point to internal instabilities, where meltwater would accumulate in massive subglacial lakes, only to find a sudden escape route and surge out in a torrent. Others suggest that the very structure of the ice sheets made them prone to catastrophic collapse, like a dam made of ice finally giving way under its own weight. A third, more complex theory involves the intricate dance between ice, ocean, and climate. As the climate warmed, it may have destabilized the floating ice shelves that buttressed the land-based ice, allowing glaciers to flow into the sea at an accelerated, unpredictable pace. The precise sequence and cause of each individual pulse remains one of the great unsolved puzzles of paleoclimatology. How could such events not leave an indelible mark on human memory? For the hunter-gatherer societies living along those ancient, now submerged coastlines, these rising waters would have been a relentless, existential threat. Vast territories rich in resources would have disappeared beneath the waves, forcing mass migrations and creating a powerful cultural narrative of loss. It is not difficult to see how the memory of these real, global inundations could have been woven into the fabric of myth, evolving over thousands of years into the countless stories of a great flood found in cultures from the Mesopotamian epic of Gilgamesh to the biblical account of Noah. These myths may be the distant echo of a time when the oceans themselves rebelled, swallowing entire landscapes and reshaping the course of human settlement. The legacy of the meltwater pulses is a world fundamentally changed, a reminder that some of the most powerful forces in our planet's history are not fire or impact, but the quiet, unstoppable power of water and the profound mysteries that remain locked within the slow, relentless death of an ice age. Deep beneath the tranquil waters of the Chesapeake Bay lies the scar of a forgotten collision. 35 million years ago, a massive bolide, a rocky object from space, slammed into the Atlantic coastal plain with the force of millions of nuclear weapons. The resulting crater is one of the largest and best preserved on Earth, but you cannot see it. It is completely buried, hidden under hundreds of meters of sand, silt, and rock that accumulated over millions of years. We only know of its existence thanks to the tools of modern geology. Seismic surveys, which work like underground sonar, have mapped its immense structure, revealing a fractured bowl 52 miles wide. Core samples pulled from deep below the surface contain shocked quartz and glassy tektites, minerals that only form under the extreme pressures of a hypervelocity impact. These are the undeniable fingerprints of a cosmic catastrophe. The immediate aftermath would have been apocalyptic. The impact likely vaporized a vast volume of seawater and rock, blasting material high into the atmosphere. The collapse of the transient crater would have generated colossal tsunamis that radiated outward, scouring the ancient coastline and hurling marine debris far inland. The environmental chaos that followed is harder to reconstruct. How did this event affect the global climate? Did it trigger a period of cooling by filling the skies with dust, similar to other large impacts? The answers are frustratingly elusive. Millions of years of erosion, sedimentation, and the relentless churn of tectonic activity have acted like a geological eraser, smudging the evidence of the impact's long-term consequences. We are left with a clear picture of the instant of the strike, but a blurry, incomplete understanding of its planetary aftermath. This makes the Chesapeake Bay crater a different kind of mystery. It is not a debate over whether the event happened. The proof is solid. The enigma lies in what it truly meant for the world of 35 million years ago. How did regional ecosystems teeming with early mammals and marine life recover from such a localized shock? Did it contribute to a known period of minor extinction? The crater holds these secrets close, a buried testament to our planet's constant and often invisible dialogue with the cosmos. It reminds us that a history of violent change can lie just beneath our feet, hidden by the peaceful surface of the present. The ghost of a vanished ocean lies scattered across the North American plains. Long after the great Missoula Floods, another colossal body of water, Glacial Lake Agassiz, held dominion over the continent's heartland. For centuries, this immense lake, larger than all of the modern Great Lakes combined, was a stable feature of the post-Ice Age world. Then, around 8,400 years ago, it simply vanished. The geological evidence for its catastrophic release is written in the land itself, from the vast, empty lakebed plains of Manitoba to the deeply scoured channels that point toward the Hudson Bay. This was not a slow drainage, but a sudden, catastrophic outburst that poured a volume of fresh water almost inconceivable into the North Atlantic. The force of this deluge would have reshaped coastlines and dramatically altered the salinity of the ocean, but its most profound impact may have been on the climate of the entire planet. Deep within the ice cores of Greenland, scientists have found a precise and alarming signal. At exactly the same time as the lake's disappearance, global temperatures plummeted in an event known as the 8.2 kiloyear cooling. A chemical shift in the ancient ice reveals a sudden, sharp return to near-glacial conditions that lasted for more than a century. The timing is too perfect to be a coincidence. The leading theory suggests that the colossal pulse of fresh water from Lake Agassiz acted like a switch, shutting down a crucial component of the global heat conveyor belt known as the Atlantic Meridional Overturning Circulation. This current, which brings warm tropical waters northward, relies on dense, salty water sinking in the North Atlantic. The Agassiz flood diluted that salinity, making the water less dense and preventing it from sinking. The engine of the current stalled, and the northern hemisphere was plunged back into a deep chill. Yet, the exact sequence of this cataclysm remains a subject of intense investigation. Did the lake drain in a single, monstrous event, or was it a series of smaller, rapid pulses? What was the final trigger that caused the ice dam to fail? Was it the slow, persistent warming of the climate, or a sudden geological event like an earthquake? The answers are locked within the complex sediment layers surrounding the old lake basin, where each layer of silt and sand tells a part of the story. This event stands as a powerful testament to a fundamental truth about our planet. A local geological change, the draining of a single lake, can ripple across the entire globe, disrupting climates and challenging ecosystems. It forces us to confront the delicate balance of the Earth's systems, where a single event in a forgotten landscape can echo for generations, leaving behind a cold signature in the ice and a stark warning about the interconnectedness of our world. Off the coast of New Zealand, a different kind of mystery hides beneath the waves. The Mahuika crater hypothesis points to a potential comet impact around 500 years ago, a geological event so recent it echoes in human memory. The evidence comes from two very different sources. On the shores of Tasmania and New Zealand, researchers have found layers of sediment filled with tiny glassy blobs called tectites, which form only under the intense heat of a cosmic impact. These same sediment layers also contain charcoal and ash, suggesting widespread, intense fires that scorch the landscape. The most compelling clue, however, may come from the oral traditions of the Aboriginal and Maori peoples. Their histories speak of a time when the sky was rent by a great fire, followed by a colossal tsunami that devastated coastlines. These stories, passed down with remarkable precision for generations, describe a cataclysm that aligns strikingly with the geological findings. It is a powerful intersection of folklore and science, where ancient stories seem to give a human voice to the silent evidence in the soil. Yet, for all these compelling threads, the case remains officially unsolved. The central piece of evidence, a definitive impact crater, has not been found. Skeptics suggest the tectites and fire layers could have originated from a smaller, more localized event, or even from a volcanic explosion. The precise dating of the event also remains a subject of debate, hovering around the 15th century but lacking the exact pinpoint that would cement the theory. This unresolved mystery serves as a profound reminder that our planet's story of catastrophe is not confined to the distant past. It urges us to look more closely at the recent geological record and to listen more carefully to the cultural knowledge of indigenous peoples, whose histories may hold crucial keys to understanding the turbulent world we all share. A single dark line in the Earth tells a story of a world on fire. Stretching from California to the Carolinas, a geological layer known as the Black Mat marks a violent turning point in North America's prehistory, dated to around 12,800 years ago. This is not ordinary soil. It is a concentrated band of charcoal, soot, and organic matter that speaks of continent-spanning wildfires. Mixed within this dark layer are microscopic particles of nanodiamonds and tiny spheres of glass, materials that form only under temperatures and pressures far beyond those of any forest fire. These are the calling cards of an immense, instantaneous force, the kind generated by an extraterrestrial object exploding in the atmosphere or striking the ground. The theory suggests a comet or asteroid fragmented and rained fire upon the continent, igniting the landscape in a synchronized, terrifying blaze. The timing of this event is precisely where the mystery deepens. The Black Mat layer sits like a tombstone directly atop the last evidence of the Clovis people, a sophisticated culture of big game hunters known for their distinctive stone spear points. In that same instant, the fossil record falls silent for the great megafauna, creatures like the mastodon and the saber-toothed cat, their bones often found just below this dark line, but never above it. It presents a stark picture, a single, catastrophic day that may have reshaped an entire continent. Yet the origin of these fires remains one of the most heated debates in archaeology. Could a rapidly shifting climate at the end of the Ice Age have created tinderbox conditions where a single lightning strike was all it took to unleash an inferno? Or does the presence of exotic minerals point unequivocally to the skies? The debate forces us to confront the fragility of ancient ecosystems and the vulnerability of even the most successful human cultures. How does a society vanish, leaving behind only a dark scar in the earth and a legacy of unanswered questions? The black mat is a humbling reminder that our planet's history can be rewritten in a flash, and that the evidence for our most profound losses is often buried in plain sight, waiting for us to decipher its fiery code. 5 million years ago, the Mediterranean Sea was a ghost of itself. The mighty basin had become a desert, a vast, sun-baked canyon lying 2 miles below the world's ocean level, dotted with hypersaline lakes. Then the ground at its western gate gave way, the natural dam at the Strait of Gibraltar fractured, and the full force of the Atlantic Ocean began its thunderous descent. This was the Zanclean Flood, a cataclysm of water that roared into the empty basin for up to 2 years, refilling the entire Mediterranean Sea in what might have been a geological instant. The evidence for this event is carved into the landscape itself. Submarine canyons, deeply incised into the continental shelf, show the paths where unimaginable torrents of water scoured the earth. On the seafloor, scientists have mapped colossal deposits of sediment, chaotic layers of sand and gravel that were carried in from the Atlantic and dumped in immense, sprawling fans. These are not the gentle leftovers of a slow sea level rise. They are the violent signature of a deluge that would have generated a continuous waterfall with a flow rate hundreds of times greater than the Amazon River, its roar echoing from continent to continent. This single event did more than just fill a basin. It resurrected an entire marine ecosystem. The toxic, stagnant lakes were flushed away, replaced by a thriving, salty sea that reconnected the isolated creatures of the Mediterranean with the global ocean, triggering a burst of new life and evolutionary change. Yet the fundamental triggers of this flood remain one of geology's great puzzles. Was it a sudden tectonic shift that lowered the Gibraltar sill, like a latch being lifted? Or was it the slow, relentless rise of global sea levels that eventually overtopped the barrier, causing it to erode and collapse catastrophically? The models disagree on the precise sequence, leaving us to wonder at the exact moment the balance tipped, unleashing an ocean to reclaim its lost territory. The Zanclean Flood stands as a monumental lesson in the impermanence of our world's geography. It reveals that even the largest seas can vanish and return, and that the maps we take for granted are merely snapshots in the long, dramatic, and still unfolding story of our planet. Beneath the serene Italian coastline and the bustling city of Naples lies a sleeping giant that has reshaped continents. The Campi Flegrei, or Phlegrean Fields, is not a single mountain but a vast, sunken caldera, a geological cauldron whose past fury defies easy comprehension. Around 39,000 years ago, this complex unleashed the Campanian ignimbrite eruption, a cataclysm that spewed a superheated cloud of gas, rock, and ash across thousands of miles. The evidence of this event is a layer of volcanic deposit found from Eastern Europe to the Russian plains, a stark testament to an explosion that would have plunged the hemisphere into a volcanic winter. The timing of this eruption intersects with one of the most profound mysteries in human history, the gradual disappearance of the Neanderthals. While not the sole cause, the dramatic climate shift triggered by Campi Flegrei would have placed immense pressure on all populations, creating a world of diminished resources where only the most adaptable could endure. For the Neanderthals, this volcanic winter may have been the final, insurmountable challenge in a series of hardships, a pivotal moment that helped clear the stage for the ascendancy of our own ancestors. Today, the caldera is anything but quiet. The ground in towns like Pozzuoli visibly rises and falls in a process called bradisism, a slow, unsettling breath that reminds everyone of the immense forces slumbering below. Scientists meticulously monitor this unrest, drilling core samples that reveal a history of catastrophic cycles. Yet, predicting what this restless giant will do next is one of the most complex challenges in modern volcanology. The magma chamber beneath Campi Flegrei is not a simple pool of molten rock, but a complex crystalline mush with dynamics we are only beginning to understand. What precise combination of pressure, temperature, and new magma injection triggers a supereruption instead of a smaller event? The answer remains locked within the rock, a puzzle that blends the ancient mystery of a past cataclysm with the palpable uncertainty of our future. This ongoing threat underscores a humbling reality that some of the greatest forces shaping our world operate on timescales and with a complexity that still defies our full understanding, leaving us to live atop a landscape whose deepest secrets are yet to be revealed. Scattered across the American eastern seaboard from New Jersey to Florida lies a landscape pockmarked with mystery. Hundreds of thousands of elliptical depressions, known as the Carolina Bays, form a pattern so vast and precise it can only be fully appreciated from the air. These are not random swampy hollows. Each one is perfectly oval, with their long axes consistently aligned in a northwest to southeast direction. This uniform orientation is the first major clue that these landforms were not created by slow, earthly processes like wind or water. Geological studies of the sediment layers within the bays point to a single, violent moment of origin around 12,000 years ago. The most compelling theory suggests they were formed by a shower of cosmic debris, the secondary impacts of a fragmented comet or a series of immense airbursts that struck the Earth at a low angle, scorching the ground and blasting out these vast, watery craters in a single, terrifying event. The timing is provocative, aligning closely with the onset of the Younger Dryas cold period and the black matte layer found elsewhere. Could the Carolina Bays be the splash marks from the same cosmic catastrophe that triggered a global winter? The debate is fierce. Some researchers argue the orientation and shape are perfectly consistent with a hail of material from a single point in the sky, while others propose alternative, gradual origins like ancient wind-driven ponds or even the collapse of peat beds. Yet the sheer number and geometric consistency of the bays present a monumental challenge to any purely terrestrial explanation. They stand as a cryptic, sprawling monument to a potential disaster, written not in a single dark line, but in the very shape of the land itself. This invites a profound question: how many other ancient landscapes hold similar cosmic signatures, waiting for us to recognize the pattern? The Carolina Bays remain an open question, a silent, water-filled testament to a day when the sky may have fallen, leaving behind a mystery as wide as the horizon. A civilization's final moments were preserved in volcanic ash. On the island of Thera, a thriving Bronze Age town was frozen in time, its multi-story buildings, vibrant frescoes, and everyday objects entombed where they lay, offering a poignant snapshot of life abruptly interrupted. This was the work of the Minoan eruption, a cataclysm whose geological fingerprints stretch far beyond the caldera that now forms Santorini. A distinct layer of this same ash has been identified in deep sea cores across the eastern Mediterranean and in ice cores drilled from the Greenland ice sheet. These far-flung signatures allow scientists to correlate the event on a global scale, yet this very process has revealed a stubborn mystery. Radiocarbon dating of an olive branch buried in the ash points to one date, while the acidity signal in the ice layers and narrow tree rings in ancient Irish oaks suggest another. The discrepancy is a matter of decades, but in the tight chronology of the ancient world, those decades matter immensely. They hold the key to understanding the precise chain of collapse that rippled across the region. The immediate physical consequences were bad enough. Tsunami deposits found on the northern coast of Crete, layers of sea sand and shell thrust far inland, testify to a wave of staggering power that would have demolished the Minoan fleet and their vital port cities. A blanket of ash, in some places dozens of feet thick, smothered farmlands on nearby islands, rendering them infertile for a generation. But the larger question is one of climate. Did the volume of sulfur aerosols blasted into the stratosphere by Thera create a measurable volcanic winter that chilled the entire northern hemisphere? Some climate models suggest a temporary cooling of 1 or 2 degrees Celsius, enough to disrupt harvests and strain food supplies for civilizations as far away as Egypt and Mesopotamia. This is where the dating discrepancy becomes critical. If the eruption aligns with a known period of political unrest and famine in these ancient empires, it could be seen as a primary trigger. If it does not, its role shifts to that of a contributing stressor, one dramatic event among many in a fragile, interconnected world. The search for the truth continues in the layered archives of the earth and ice, a testament to how the fate of human societies has always been intertwined with the restless power of the planet. The invisible shield that protects our planet briefly flickered out. Around 41,000 years ago, Earth's magnetic field underwent a dramatic reversal in an event known as the Reshaped excursion. For a period of roughly 1,000 years, the magnetic poles wandered, and the field's strength collapsed to a fraction of its normal power. We know this not from historical records, but from a geological clockwork frozen in volcanic rock. When lava cools, magnetic minerals within it align themselves with the planet's magnetic field at that exact moment, preserving its direction and intensity like a cosmic compass needle. Sediment cores drilled from ocean floors tell the same story, with layers of magnetic particles settling in alignment with this weakened field. The evidence is unequivocal: our planet's protective barrier faltered. With a magnetic field so diminished, a far greater amount of cosmic and solar radiation would have reached the Earth's surface. This invisible rain of high-energy particles would have increased mutation rates in living organisms and posed a significant challenge to any life on the planet. Researchers have found a compelling and chilling link in the ice. Cores from this period show a spike in radioactive isotopes like beryllium-10 and carbon-14, which are created when cosmic rays strike the atmosphere. The atmosphere itself was being chemically marked by the influx of radiation from deep space. The potential consequences ripple through the fossil record. This period coincides with the extinction of the last Neanderthals and the decline of other megafauna. While not the sole cause, the increased radiation and potential climate disruptions linked to the excursion would have placed immense stress on ecosystems and the species struggling to survive within them. It presents a haunting scenario where an invisible shift deep within our planet could have altered the very fabric of life on the surface. Yet the fundamental drivers of such a reversal remain one of geophysics' greatest mysteries. The magnetic field is generated by the churning of molten iron in Earth's outer core, a chaotic, dynamic system that operates like a colossal engine. What causes this engine to suddenly stutter and attempt to reverse itself? The forces at play are so vast and deep that we can only model them indirectly, leaving the ultimate trigger for the Reshaped excursion hidden within the turbulent heart of our world. This event forces us to confront a profound reality: that some of the most powerful cataclysms are not marked by fire or flood, but by the silent, unseen weakening of a force we rely on every moment, a reminder that our planet's greatest dramas are often written in magnetism and stone. A secret lies buried under a mile of ice in northern Greenland. Hidden for millennia, the Hiawatha crater is a geological phantom, a 31-kilometer-wide scar left by a massive asteroid impact. Its discovery was a triumph of modern technology, revealed not by a shovel, but by radar waves that penetrated the thick ice sheet to map the contours of the land below. The data painted a stunning picture, a perfect circular basin with a raised peak at its center, the classic fingerprint of a high-velocity impact. Sediment samples washed out from beneath the glacier contained shocked quartz and other minerals that form only under the extreme pressures of such a collision. The evidence is clear: a colossal rock from space struck this very spot. But the moment you ask when it happened, the mystery deepens. The immense challenge of dating a structure buried under an ice sheet means its age is still uncertain, with estimates ranging wildly from the end of the last ice age to several million years ago. This single question, when, holds the key to understanding the crater's true role in Earth's history. If the impact occurred toward the end of the Pleistocene, around 12,000 years ago, the consequences would have been immediate and catastrophic. The energy released would have vaporized a vast portion of the ice sheet, instantly flooding the local region with meltwater. The blast would have hurled immense quantities of dust and water vapor high into the atmosphere, potentially disrupting global climate patterns for years. Could such an event have contributed to the sudden cold snap of the Younger Dryas, or even accelerated the final retreat of the ice sheets? The possibility is tantalizing, suggesting a direct link between a cosmic impact and the closing chapters of the Ice Age. Yet, without a precise date, it remains a compelling theory. The Hiawatha crater stands as a powerful reminder of how much of our planet's violent history remains hidden from view, preserved under frozen wastelands or deep ocean floors. It forces us to wonder how many other cataclysms are still waiting to be found, their stories locked in ice, silently shaping our understanding of a world where the past is never truly past. The power of a single lake to carve a continent is written across the Snake River plain. While the Missoula Floods were a repeating cycle of destruction, a different kind of deluge ripped through Idaho in a single, monumental event. This was the Bonneville Flood, a cataclysm born from the sudden failure of a natural dam holding back ancient Lake Bonneville, the massive predecessor to today's Great Salt Lake. Around 14,500 years ago, that dam gave way. The resulting flood unleashed a volume of water so immense it would be difficult to overstate its force. For weeks, a torrent equal to the combined flow of every river on Earth surged through the landscape with a roar that must have shaken the continent. The evidence of its passage is permanently etched into the land. The floodwaters scoured out the Snake River Canyon, carving through solid basalt and leaving behind towering cliffs and immense potholes. They stripped the land down to its bedrock, sculpting features like a colossal waterfall that once dwarfed Niagara. Most telling are the gigantic ripple marks, waves in the earth itself that stand 30 feet high and are spaced hundreds of feet apart, a permanent record of water moving at speeds faster than any modern river. These are not the gentle marks of a slow river, but the violent signature of a single, earth-shattering event. But what was the final trigger that caused the lake to break its bonds? The lake had been stable for centuries, so what changed? The leading theory points to a process of gradual erosion at the lake's outlet, a slow, persistent wearing away of the rock barrier that finally reached a tipping point. However, some researchers wonder if a sudden trigger, like an earthquake in the tectonically active region, might have been the final nudge that initiated the collapse. The precise sequence of that failure remains a key mystery, a puzzle locked in the eroded sediments of the Red Rock Pass. The flood's impact on the regional ecology would have been just as profound. The sudden deluge of cold, fresh water into the river systems would have dramatically altered water chemistry and temperature, devastating local fish populations and riverside habitats. For the early human communities who may have witnessed the event, it would have been a world-altering spectacle, a reminder of nature's awesome and unpredictable power that likely entered their oral traditions. The legacy of the Bonneville Flood is a masterclass in the sheer force of water. It demonstrates that a single, rapid event can accomplish geological work that would otherwise take millions of years, leaving behind a scarred and majestic landscape that continues to challenge our understanding of how quickly our planet can be remade. 2.5 million years ago, a messenger from the void struck the most remote place on Earth. Far out in the Southern Ocean, a cosmic body, perhaps a comet or asteroid, plunged into the deep sea. There is no crater to mark the spot, no shattered landscape to bear witness. Instead, the evidence for the Eltanin Impact is found in the quiet, layered mud at the bottom of the world. Geological cores pulled from the seabed reveal a startling layer rich in extraterrestrial debris, including tiny glassy spherules and fragments of meteoritic dust. This material was scattered across a vast area, a silent rain of cosmic evidence settling into the ooze. For an event of this magnitude, occurring in water thousands of feet deep, the immediate violence would have been contained. There would have been no fireball, no colossal blast crater. The true cataclysm happened in the moments that followed, as the impact vaporized an immense volume of seawater and hurled it into the atmosphere. This single act could have dramatically altered the planet's climate. A thick, global veil of sea spray and dust, lingering for years, would have reflected sunlight back into space, potentially accelerating a cooling trend that was already beginning to grip the world. This timing places the Eltanin event at a pivotal crossroads in Earth's history, coinciding with the intensification of the ice ages and a wave of marine extinctions. Could this impact have been the final push that tipped the planet into a deeper, more persistent cold? The debate is far from settled. Some climate models suggest that even a large oceanic impact has a limited effect on global temperatures, while others point to the clear environmental disruption recorded in the same sediment layers. The mystery is compounded by the very nature of the evidence itself. How do we measure the full force of a disaster that left no traditional scar? Without a crater, scientists are left to piece together the story from secondary clues, debating the size of the object and the true scale of its environmental shockwave. The Eltanin Impact forces a profound shift in our perspective, urging us to recognize that not all cosmic catastrophes announce themselves with a fiery crater on land. Some of the most significant events in our planet's history have unfolded in the profound darkness of the abyss, their full stories waiting to be read in the subtle, layered language of the deep sea floor. A thin, global line in the rock tells the story of the world's most famous ending. Etched into the planet 66 million years ago, the K-T boundary marks the close of the Mesozoic era, a moment when the reign of the dinosaurs came to a sudden and dramatic close. This layer of clay and ash, found from the cliffs of Denmark to the badlands of Montana, holds two distinct and violent signatures. The first is a startling abundance of the element iridium, which is incredibly rare on Earth's surface but common in asteroids and comets. The second is the presence of shocked quartz, minerals whose crystalline structure was fractured by pressures only achievable in a colossal impact. For decades, these clues pointed to a single, shattering conclusion: a massive asteroid strike. The discovery of the Chicxulub crater, buried under the Yucatan Peninsula in Mexico, provided the definitive proof, a 150-kilometer wide scar that perfectly matched the timing of the extinction event. The immediate aftermath is almost beyond comprehension. The impact would have vaporized rock, triggered global firestorms, and sent a towering tsunami racing across the oceans. The sky would have filled with superheated dust and soot, plunging the planet into a long, dark winter that crippled photosynthesis and collapsed food webs from the bottom up. Yet, the story is not as simple as a single bad day. In what is now India, a different kind of cataclysm was already underway. The Deccan Traps were erupting in a series of monumental lava flows that lasted for thousands of years, releasing vast quantities of volcanic gases and potentially altering the climate long before the asteroid arrived. This presents a profound geological puzzle. Did the asteroid deliver the final, killing blow to an ecosystem already stressed by volcanic pollution and climate change? Or were the Deccan eruptions themselves intensified by the seismic shock of the impact, a one-two punch from the planet's interior and the cosmos? The exact sequence of these events and their individual roles in the extinction remains a vibrant and evolving debate. This boundary layer, therefore, is more than just a tombstone for the dinosaurs. It is a complex archive that forces us to reconsider the nature of catastrophe itself, revealing that the greatest endings are rarely caused by a single villain, but by a tragic convergence of forces, both earthly and extraterrestrial. The K-T event stands as a humbling benchmark in deep time, a reminder that our understanding of even the most studied cataclysms is never truly complete, constantly refined by each new discovery pulled from the stone. A strange, cold twilight fell across the world in the year 536. For 18 months, a mysterious dust veil dimmed the sun, casting a pale, copper shadow that blotted out its warmth and brought a lingering frost to summer mornings. This was not a local phenomenon, but a global climatic shock whose evidence is locked in the planet's most precise natural archives. Deep within the ice caps of Greenland and Antarctica, a core sample reveals a stark, sulfuric acid spike from that very year, the chemical ghost of a colossal volcanic eruption that polluted the stratosphere. At the same time, on the other side of the world, the rings of ancient trees from Europe to North America tell the same story of hardship. Their growth bands become desperately narrow, showing years when the sun's energy faded and the world simply went cold. The geological data paints a clear picture of a planet in distress, but the central mystery remains stubbornly unresolved. What was the exact source of this veil? The leading theory points to a massive volcanic event, perhaps in Iceland or North America, that ejected enough sulfurous ash high into the atmosphere to act as a permanent solar shield. Yet, some ice core data and fragmented historical accounts from China and Europe also describe celestial portents, leading a few researchers to wonder if a comet impact or airburst could have thrown up its own global pall of dust. The debate continues because no single definitive crater or caldera has been conclusively linked to this precise moment. The true magnitude of this natural disaster is measured not just in ice chemistry, but in profound human cost. Historical records from across the globe speak in unison of a time of unprecedented crisis. The Byzantine historian Procopius wrote of a sun that gave no more light than the moon, and of a warping climate that brought famine and illness. From Ireland to Mesopotamia, chronicles tell of failed harvests, mass migrations, and the social unraveling that follows when the basic foundation of survival collapses. This period is now seen by many historians as a pivotal turning point, potentially contributing to the decline of the Roman Empire, the great migrations across Europe, and even political upheaval as far away as China. The event of 536 stands as a stark lesson in the interconnectedness of our world, where a single geological or cosmic event can ripple through human societies, testing their resilience to its very limits. It reminds us that civilizations, for all their grandeur, exist in a delicate balance with the natural world, a balance that can be tipped by a distant fire from the earth or the sky. The ongoing search for its origins, combining ice core science, tree ring analysis, and historical detective work, shows how the deepest mysteries of our past often require us to read the Earth's story and our own as a single, intertwined narrative. These 20 geological enigmas, from the ghost of Doggerland to the frozen scar in Greenland, reveal a planet far from serene. Each layer of rock and ice tells a story of sudden, transformative power, where the ground can give way, the sky can fall, and the seas can rise with a force that rewrites history. The common thread woven through these mysteries is not just the evidence of destruction, but the profound gaps in our understanding that remain. For every impact crater we find, there is a missing trigger for a global freeze. For every buried city, a debate over the precise moment its world ended. These are not just academic puzzles, they are urgent reminders of the dynamic and often unpredictable world we call home. By studying the forces that shaped our past, from cosmic collisions to volcanic supereruptions, we gain a clearer lens through which to view our future. The same restless Earth that tested the resilience of early human societies still holds that potential today, making scientific inquiry not merely a look backward, but a vital tool for preparedness and preservation. Which of these ancient cataclysms leaves you with the most compelling questions? Share your thoughts in the comments, and if you are captivated by history's greatest enigmas, subscribe for more journeys into the unknown. Thank you for exploring these deep mysteries